Hi there, everyone. Thank you very much for joining us today for our webinar with TestForce and EA Elektro Automatik on the benefits of auto-ranging power supplies in test applications. We thank you for your attention and participation today. If you have any feedback or other webinar topic suggestions for the future, then please let me know by chat, or you can email us later at marketing@testforce.com. Before we get started, I'd just like to let everyone know that this webinar will be recorded and you'll be receiving an email afterwards with the recording. If you're interested in any of the other webinars we'll be hosting or to download any of the free resources we have available, such as white papers or application notes, please go ahead and visit testforce.com/academy and you'll find everything you need right there. If during the webinar you have any questions, make sure you ask them in the Q&A section in the right side menu bar, and we'll be sure to get to all of those questions as we come to the end of the presentation. And now I'd like to introduce Eric Turner at EA, and let's jump right in and talk about auto-ranging power supplies with Eric.
Hi, and thank you for attending this presentation on benefits of auto-ranging power supplies and test applications by EA Elektro Automatik. Today, what we're going to be viewing is some of the challenges that customers go through in selecting a programmable power supply. So one of the things you'll notice on the right is that power supplies are rated on power, and as a function, there's various voltage and current combinations available to achieve those power levels. So, one of the challenges that customers have is selecting just the right voltage and current combination for this specific product that they're, trying to test. You can see on the right, there's over 60 different models for this. Another one is, what if the power supply has several different input voltages? How do you test that product? Sometimes the method of testing a product with multiple different input voltages and power levels is actually oversizing the power supply. So we'll take a look at a couple examples of that as well. And two, really just getting a power supply that fits your today's needs and not really planning for the future. Sometimes obviously CapEx and budgets are constrained and they're really just looking at what they can do now instead of really being able to plan for the future. So let's take a look at auto-ranging, kind of the theory of operation. Auto-ranging is just a term, and it basically describes the power supply's ability to automatically adjust its output level from a current perspective to maintain that full power output across a larger operating envelope. So what you'll see in the yellow is what we call kind of a traditional standard square operating curve power supply. And to the right, you'll kind of see where the extra range fits into this. And really the result of this is that you end up with a full power output across a very large range. The power supply can be able to test a lot of different products and really oversizing that power supply. You don't really need to do that with an auto-ranging power supply to the extent that you would with a square operating curve. So let's go ahead and take a look at some specific examples. So here, for the theory of operation, we have a 15 kilowatt power supply that's capable of 500 volts and 30 amps. Part of the challenge that customers have is, how often do you actually operate at 500 volts? Maybe it's 450 volts, maybe you're down to 300 volts, 150 volts. So, as you program down in voltage, the available current from that power supply stays the same, meaning the power supply will never provide more than 30 amps of current, 500 volts, 15 kilowatts. So as you're programming down in voltage, say at 250 volts, you're still getting that 30 amps, you're only at 7,500 watts. So here you purchased a power supply that's capable of 1500 watts, but at half the voltage, you're only getting half the power. That obviously gets worse when you get down into even lower voltages. Let's say at 166 volts, you're looking at a 5 kilowatts. So here, you acquired a 15 kilowatt power supply and you're only actually able to get 5 kilowatts out of it. Okay. So this is just some of the limitations that come with a square operating curve power supply. So now let's take a look at an auto-ranging power supply. Okay, so one of the things you'll notice is the first thing is we went with a higher voltage model. Yes, you could get a 500 volt auto-ranging power supply, but why would you? Why not go to 750 volts again, plan for the future when you know you can still hit your voltage and current combinations and those cardinal points that you need from a power perspective. So again, 750 volts, 20 amps, you got your 15 kilowatts. Program down in voltage, say down to that 500 volt mark, and you're still at that same 500 volt, 30 amp, 15 kilowatts that you were with that other power supply. So again, program down even further in voltage. Let's say you're down to that 250 volt mark where, we saw we were getting 7,500 watts from the other power supply. An auto ranging power supply is going to increase its current to 60 amps. And again, you're still maintaining that full 15 kilowatts from the power supply. Okay, let's go ahead and take a look down at the 166 volts. Okay, auto ranging is not infinite. It does not go on forever. There is a limitation at some point. Even auto ranging power supplies start to limit the amount of power that they can output. But remember that 166 volts that we looked on in that square operating curve, you were down at less than 5 kilowatts. And with an auto ranging power supply, you're sitting right at around 10 kilowatts. So again, we're providing twice the power that a square operating curve at those lower voltages. Okay. So when you start taking a look at auto ranging power supplies, again, taking those 60 models, because you don't have so many voltage and current combinations, that the model selection is greatly reduced, the number of models. And a lot of times what comes with that is, one, it simplifies purchasing. You have one model number in there that you maybe need to buy, say a 750 volt, yet you covered all those different applications with a single model. Configuration control, when you start taking a look at ATEs and things like that, being able to limit the number of models that are in there, serviceability, everything that goes along with the benefits of having less models and, keep that consistency throughout your test stands. Let's take a look at some examples here. Here's one example of an auto ranging power supply driving a Vicor power supply. So one of the things here you'll see is the Vicor power supply is a multiple input voltage power supply for the same power pack. Okay, so what you'll see is the nominal is from 12 volts to 72 volts, yet the low end is actually 10 volts and the upper end is 100 volts. The power supply is rated for 1600 watts. And so what you'll see here is that you need to achieve both the 100 volts, but you'll also need to achieve the 1600 watts, 10 volts equals 160 amps. So the customer, to test this 1600 watt power supply is going to have to, basically get a 100 volt, 160 amp power supply to be able to drive this. So what you'll see on the right is the various solutions. So the first one you'll see is an auto ranging power supply, right? It's 15 kilowatts, obviously plenty of power, 200 volts. So it's twice the voltage that's needed. And the current is slightly higher, at 210 amps. Okay. Over on the right, what you'll see is square operating curve power supplies. So for this particular application, the customer could have selected 100 volts, right? It's hitting the 100 volt that he needs. So technically it's working for this one particular application. And the current is 200 amps. You get your 20 kilowatts. So, and, likewise down below. So one of the things you'll notice here, well, probably multiple things, is first, it's a 20 kilowatt versus 15 kilowatts. A lot of time power supplies, their cost is $1 per watt. So it's not that auto ranging power supplies are necessarily any less expensive $1 per watt, but you're losing a less powered unit, 15 kilowatts versus 20 kilowatts. Also, too, we talked about planning for the future. We doubled the voltage. The auto ranging power supply gives you that ability to say, hey, I know I only need 100 now, but what if I need to test at 110 volts or 115 volts into the future? Hey, I can get a 200 volt auto ranging power supply, still covers my application at 100 volts. I'm good to go. And so if you look over on the right, the other models, you're at 100 volts, 200 amps. So the auto ranging power supply is providing 10 more amps and is also a more cost-effective solution and is also half the size. The 20 kilowatt power supplies you see on the right are a 6U chassis versus a standard 3U chassis. Okay. So let's take a look at some other examples. Data centers, the war continues between AC and DC. Okay, what's going on right now is what you see on the top is the least, what they're calling the least efficient method for providing power to servers to data centers, right? Data centers are obviously a huge and enormous amount of power consumption, and so increasing efficiencies with data centers can result in significant cost savings. And so one of the things they're looking at right now is when you see on the top is that the utilities brought in through a medium voltage transformer usually goes through a UPS. That then goes through a power distribution unit, and then it goes into the AC input into the server rack. Well, the conversion from AC to DC is done at the macro level at the rack. And what scientists and people have said is, look, through our analysis, that the most efficient way would bring it in and just actually rectify it right from the utility line, feed high voltage DC throughout, and not do the conversion at the macro level, but do it at the major level. And so, as a result, what they're taking a look at is providing, voltage, DC voltage throughout server farms. The nominal voltage for this is right around 400 volts. However, they operate as low as 260 volts and up to 530 volts. So in this particular example, the router and everything is still going to pull a full 60 kilowatts at that 260 volts DC. So you're looking at 230 amps, right? So that's the low end. That's the low end of the low voltage, high current condition. The other likewise is, hey, we need to go as high as 530 volts. Well, okay, your current's a lot less, but now you have to hit that 530 volts. So with a standard square operating traditional power supply, you have to calculate both the 230 amps DC and the 530 volts DC. Multiply that together, you get your 138 kilowatts. So again, this is another example of where just because you have these high voltage, low current, low voltage, high current conditions, that the result is that the power supply non-auto ranging would have to be twice the power level, more than twice the power level of the actual server. Okay, so let's take a look at auto ranging power supplies. Again, we take that 60 kilowatts. What we decided to do is say, hey, let's take two 30s, put it in parallel. One, you'll notice you're getting that 750 volts, well beyond the 530 volts that required. So there's plenty of headroom for planning for the future. It provides up to 2 units in parallel, up to 240 amps DC. So 60 kilowatts, 260 volts, you get your 230 amps within the capability. And again, certainly the voltage within capability, 113, you're good to go. So again, in this particular example, you're looking at the auto ranging solution is about half the power and results in about a 45% cost savings over a standard power supply. Let's take a look at some kind of renewable energy stuff. So what you'll see here is a very typical setup for solar array. The solar provides DC through an inverter. The inverter then feeds it back to the utility grid or maybe to a battery storage device. Pretty high voltages here. And so, in this particular application, let's take a look at the solar array because it does have actually a very large operating envelope. So what you'll see here is just a typical ABB PV inverter. The PV inverter is rated for 6,800 watts. The maximum voltage into it is, 520. But what you'll see here is the startup voltage is actually 200 volts. So again, you have this wide operating condition. And maximum current at maximum power point at startup is going to be, say, 48 amps. So take that 520, 48 amps. Again, you need to select a power supply that provides both of those. So over on the right, we have a 750 volt power supply that meets the requirements for the 520 volts. You got your 60 amps, so you're meeting at 48 amps. Yet with a standard operating power, square curve operating power supply, you'd have to be up into 25 kilowatts. You'd be limited, fairly limited on voltage and just right at the current that's available for this PV inverter. So again, just looking at it, cost savings, size savings, higher voltages, higher currents, all the benefits of auto ranging. Another kind of fun application, e-mobility, obviously a lot going on in this market right now. And so what we have here is another example of onboard chargers. Two different onboard chargers. There's a 500 volt model and a 800 volt model, both rated at 22 kilowatts. Again, so what you'll see here is a couple operating curves. The first curve is, the red curve that you'll see from a auto ranging power supply. So we selected a 1500 volt. Again, you can get a 1000 volt auto ranging power supply, but why would you? We cover the 800 volts. Let's go into higher voltages. Let's plan for the future. What if it's increasing? What if in a test condition, you need to get out of the way up to 900? What if that 900 actually goes higher? So again, what you'll see here is the gray and the blue is the 800 volt power supply, pulling right around 28 amps, and also this 400 volt power supply right around, 55 amps. So traditionally, if you wanted to, use a traditional power source, you'd have to take the 55 amps, multiply it by your 800 volts. You're looking at like a 44 kilowatt power supply to test this 22 kilowatt, onboard charger. So here you'll see basically these different voltage current levels hit all the voltage and current combinations that are going to be needed out of that power supply. Okay. So in summary, auto ranging power supplies, they simplify model selection. They really maximize flexibility, often result in space savings and or cost savings, or a combination of both. So you want to see auto ranging in action. You can go out to our YouTube video on EA Elektro Automatik's channel and be able to see auto ranging in action, real time. And we appreciate you coming today and attending. Just a little bit about EA Elektro Automatik. We are headquartered out of Viersen, Germany. All of our manufacturing is done in Germany, and we have subsidiaries across the world for worldwide customer support. We manufacture and design power supplies and loads from 320 watts up through 2 megawatts of power, up to 2000 volts DC. All of our power supplies are auto ranging. We do not offer any square operating curves power supplies. We offer both linear and regenerative DC loads, bidirectional power supplies, and industry leading efficiency. It is up to 94+% efficient on all of our regenerative loads and power supplies. We appreciate your time today. Thank you. Thank you, Test Force. We appreciate you hosting this, and we look forward to talking to you. Thank you very much.